Hi there, this is Rajavari, and I'm a member of Group 1. We have Joshua Kane and Nathan Coyle, which are the other two team members of our group, and we're going to talk about our water and environmental sensor. In today's presentation, we're going to include the talk agenda, which some of it is abstract, introduction, background, project objectives, methodology, timeline and budget, conclusion, and references we used to gain information. Starting with the project, our project will be an environment and a water sensor, and we're going to make use of a large number of peripherals to collect the readings and display them. One of our system goals is to be able to read multiple sensors and take accurate readings of the temperatures, humidity, and water levels, etc. One of the further steps we would like to take is to implement a way to capture all the readings, to capture all the pH readings of the water with a pH meter and display it. All of these measurements are constantly changing everywhere in the world due to global warming, which also results in Earth's environmental degradation. Hence, our system goal is to let users collect and trust their own environmental data readings of the temperature, humidity, and water levels.
So, introduction of our project is the purpose just to have a full system to take various environmental sensors. It's going to be controlled by the Mega R3 microcontroller, with an increased emphasis being placed on the environment and ocean acidification. Our project aims to let users capture their own data that lets them see how their own local environment is being affected by mankind. So our completed system will allow users to create, capture multiple different ratings of temperature, humidity, user motion sensors, ultrasonic ratings of distance, and various others, with a keypad to cycle through the readings. So just to talk about the background more, in our advanced society, we're continuing to use fossil fuels. One of the most overly, underlooked aspects is how fossil fuels affect our ocean. Our ocean's becoming more acidic. At a certain level, the pH levels for phytoplankton are going to be too bad, and all the phytoplankton are going to die. And then oxygen being produced, oxygen, the carbon cycle in our ocean is going to be fucked. So it's not going to be, we're not going to have as much oxygen as we have now. So that's kind of what we aim to look and monitor. So here's some of our project objectives. We had quantifiable, date-driven objectives. So buy our kit. We have already bought all of the project peripherals. We have started the physical construction of our system. We have also added a separate Word document to monitor our code progress of the physical peripherals. We have also created a Gantt chart and logged our project work. We have edited and created a project cost breakdown pie chart. We have not started testing the system as we have not completed physical construction, and once we are done with the project construction, we can start taking measurements and documenting the data with the completed system. So the methodology of our project, this picture to the right shows some loose peripherals and the components of the system we were using to build, and the picture to the left shows a completed block diagram of our system. Josh, do you want to take over?
Yeah. The sensors used for our project will be a 3-pin DHT This is humidity and temperature sensor, captures values of water vapor saturation and temperature. A water level system, or a water level sensor, which reads how submerged the device is with no water contact in 520 if it's fully submerged. A pH tester, which will be used to gather pH values. An ultrasonic sensor HCSR04, which will measure the distance between itself and an object in its forward path. An LCD, which is used to show the system sensor readings. We'll use a membrane keyboard to cycle through the various sensors. These will be assigned to letters and numbers. The Eligo power supply module, which will power the system IR receiver module to receive remote control signals. The remote control, which sends signals to switch display values. The PR motion control sensor, which measures the proximity of users. We'll be using a passive sensor, which will sound when water level sensor is at a max value of 520. Methodology continued. For the system modeling and algorithms, we're compiling code and linking the peripheral base code. This is in a separate Word document, which has many pages of code. Our tools for the project objective will be our complete system to take the readings, external pH meter, a phone so we can take the video when we're collecting data, a cup to hold water, and a pH up and down bottles to lower or raise the pH value. For our project budget, the total system cost was $65.90, and shown below is a pie chart with all the various sensors and components and their percentage of cost. So here is the Gantt chart, which has our objectives and basically a timeline of when we plan on completing them. So buying the kit and supplies, we started that October 20th and ended that November 1st. Starting the physical construction, we started that November 3rd and are expecting to finish it November 16th. Starting the MP lab project code, we started that November 1st and expect to finish that November 16th. Started logging the work in Gantt chart. We started that November 1st and I guess basically ended that when we're done with our proposal, but I guess we're kind of going to continue to add to that anyways.
Yeah.
For editing the cost pie chart, we started that November 3rd and expected to finish that November 16th. Start testing the system. We haven't started this yet, but we are expecting to start that November 16th and finish that around November 22nd. Start taking measurements and documenting the data. We're starting that November 20th and expecting to finish that December 1st. Preparing for our demonstration, we are starting that November 22nd and expecting to end that December 1st.
Last one.
The conclusion, our project aims to let people collect accurate data about their local ecosystem in several ways. Our main motivation for this topic was climate change becoming a prevalent political issue in America and other countries around the world. Once the project has been constructed, data will be able to be gathered, and we can take sensor readings in the same location over a duration of a week and record these findings in a video. The location chosen to do this was the backyard of Nathan Coyle.